This is the second solving equations video. I am Ms. McCool and I am working with you on the learning target. I can combine like terms before solving an equation. This video goes with the Equations 2 worksheet. And if you are watching this video, you should have already completed the top portion of that worksheet. In the top part, you review combining like terms, and you should check your work with the answer key. The answer key does not show any work supporting that final answer, and actually that is acceptable in algebra. We expect that most students are able to correctly combine like terms within an expression without needing to show any work, and that is just fine. However, it is also just fine if you prefer to show some work here. So for example, in this expression, if it helps you to rewrite the expression so that the like terms are together, 20 minus 5 plus 3x plus 9x plus 2x. That is completely acceptable to show that work. So to have a line right here before your final answer. And then I would have 20 minus 5 is 15 plus 3 plus 9 plus 2 is our coefficient, 3x plus 9x plus 2x. That's going to be 3 plus 9, which is 12, plus 2, which is 14. Oh, and look at this. My final expression here actually looks a little different than the answer key. 14x plus 15 is an equivalent expression to 15 plus 14x, and this would be a completely acceptable answer for us. If you have these two terms reversed, 27 plus 13h, that is completely fine. Although actually this answer key version is the slightly more sophisticated answer that we would prefer with that variable term first. But if you have 7 plus 5y, that is just fine. If you're finding that you're struggling with this a little bit, you can review combining like terms with the 6th grade introductory algebra textbook. If you don't actually have that textbook, you can go to the online Core Focus version of the textbook, lesson 2.5, and download that student text or watch the video or do some of the worksheets. In the textbook, that work where we reorder the like terms together is shown, and that is again not required but perfectly fine. Our new skill is doing that simplification or that combining of like terms before solving an equation. So here in this example, we are combining like terms in order to create a two-step equation which we are now comfortable solving. If you prefer to show that step, you could have another step in here. 9n minus n plus 1 plus 3 equals 52, before realizing that 9n minus n, that invisible one here, 9n minus 1n is 8n plus 1 plus 3, which is 4, equals 52. Again, optional, but not required. Some students prefer, rather than rewriting, to highlight or color code the like terms. So maybe with a highlighter, highlighting the 9n and the minus n, making sure, for sure, that that minus stays glued together to the n. Or you could color code by underlining, making sure that you know that the subtraction goes with the n. You could do that as well. Okay, so working on these examples, the first one actually only has one set of like terms, our x terms. So we have 3x plus 5x minus 2x equals 24. Before we perform any inverse operations at all, we need to combine those like terms so that there is only one x term. So 3x plus 5x is 8x. You could go ahead and write that, 8x minus 2x equals 24. I guess I'll do that. Not at all required. And then 8x minus 2x, we subtract those coefficients. 8 minus 2 is 6x equals 24. We now have a one-step equation, which is awesome. We are super comfortable with solving a one-step equation. 6 times x divided by 6 leaves us with x. X equals 4 is our final solution, our final answer to this equation. If I were to plug it back in, to the original equation. So if I were to tell you to perform the check, 3 plus 4 plus 5 times 4 minus 2 times 4, does that equal 24? I don't know, does it? 12 plus 20 minus 8 equals 24. 12 plus 20 is 32. 32 minus 8, yay, it is 24. You can see why some students do not super love the check. But we were checking to make sure, hey, if I plug 4 back in for each of those x values, does it equal 24? Yes, it does, so my equation is true. This does not need to be on your own worksheet. This is optional. But if we were to tell you to perform the check, this is what we would be looking for. Okay, next example also only has one group of like terms, a p term. So we're not having an x, we're having the variable be p here. So 40 equals 1p plus 5p. Let's not write that this time. Let's just keep track of that in our head. 1 plus 5, which is 6p. 6p minus 2p, which is 4p. 4p plus 4p is 8p. Again, you could show each step in that process. 1 plus 5 is 6. 6 minus 2 is 4. Don't know what's happening with my handwriting today, I'm sorry. 4 plus 4 is 8. And again, we end up with a one-step equation, but all of the stuff up here, not required. If it helps you out, great. If it doesn't, not required. One-step equation, dividing both sides by 8, and we end up with p equals 5. I prefer for the variable to be on the left-hand side. So p equals 5. And if I were to plug that back in, let's see if we get the right answer. P equal to 5, so 5 plus 5 times 5 is 25. So we're at 30. 30 minus 2 times 5, so 30 minus 10, we're at 20. 20 plus 4 times 5, which is 20. 20 plus 20 equals 40. So even if you're not asked to perform the check, performing the check in your head or if allowed with a calculator is a great idea to make sure that your solution does in fact make the equation true. Third problem, finally things get a little more interesting. We have both a y term as well as a constant term. I'm going to try the highlighting approach here. So I'm going to highlight 5y and the minus 3y. Ooh, let's do a combo. And then I'm going to underline the constants. I'm not going to rewrite it. Okay, so 5y minus 3y gives me, sorry, just a second, 2y. And then we have 3 plus 7, which is 10. 2y plus 10 equals 16. And now I have a two-step equation, and I can start performing my inverse operations. So really quickly, a lot of students will start to perform their inverse operations here without first combining like terms. Now, it will depend on your teacher if they take off any points for that, because you will still, if you perform your inverse operations correctly, you still might end up with the right answer. But I will require you to first combine like terms, 5y minus 3y plus 10 equals 16. I will require you to get to the place where you have a two-step equation before you are allowed to start using inverse operations. Okay, so no minus 3, no minus 7. We're combining our like terms before we do anything else. Okay, two-step equation. We have multiplication and addition happening. So we're going to need to perform the inverse operations of division and subtraction. The subtraction being our first inverse operation. 2y plus 10 minus 10 gives me 2y. 16 minus 10 gives me 6. I have a variable term being multiplied by 2y, so I just need to divide by 2 in order to arrive at my final solution, which is y equals 3. I am not performing the check here, but if I were, I would plug 3 back in for y and make sure that when I do so, I end up with a value of 16 on this side. Okay, I can't help myself. Let's check and make sure we're right. 5 times 3 is 15. 15 plus 3 is 18. 18 minus 3 times 3 is 18 minus 9, which is 9. And hooray, 9 plus 7 is 16. So I know that I am correct. My solution, y equals 3, does in fact make the equation true. Last example. Oh, it looks so complicated, but we are totally capable of solving this equation. All right, let's this time try the strategy of first rewriting the expression before simplifying. So we need to simplify, meaning combine like terms on the right-hand side of this equation. And I'm going to rewrite it so the w terms are together. 4w plus 2w plus 4w. And then I have my constant terms, 16 minus 2. This is, again, not required. You could instead highlight, underline, or just do it in your head. But if you're finding yourself not correctly combining like terms, we suggest that you try one of those strategies rather than doing it in your head. Okay, 4w plus 2w is 6w. 6w plus 4w is 10w. And then we have 16 minus 2, which is 14. Two-step equation, and we are ready to go with that. Here we have w being multiplied by 10 and then adding 14. So when we go in reverse order to perform those inverse operations, we're going to first subtract 14 from both sides of our equation. 34 minus 14 is 20. 20 equals 10w. One-step equation time. We are masters. Most teachers will accept 2 equals w. I have a hard time taking off points for that, but I really prefer the variable on the left side. So w equals 2 is my final answer. Checking to see that that works out. 4 times w is 8. 8 plus 16 is 24. 24 plus 2 times 2 is 24 plus 4, which is 28. 28 plus 4 times 2 is 28 plus 8, which is 36. And 36 minus 2 is 34. Hooray. Generally, we do not require the check to be written out for this complicated of an equation, but we could. And again, it's suggested that you at least check it in your head to make sure that it works. All right, now it's your turn. You're going to turn to the back of this worksheet and perform or combine like terms and then solve these 1 or 2 step equations. And then you're going to check your work with the key and or preferably with your teacher to make sure that you are showing your work correctly and completely comfortable with this skill before moving on to equations 3.